and welcome to the Warwick Christmas Lectures. Caldecote works in the physics department at the University of Warwick, sharing the awesomeness of physics with anyone who will listen. Join her for some science investigations you can do at home. Hello everyone and welcome to the Warwick Christmas Lectures. My name's Caldecote and I work in the physics department here at the University of Warwick. Usually when you come to our live events, we like to do big experiments for you, giant explosions with huge amounts of fun. My favourite part is having people from the audience come and try the experiments on stage. And I was feeling sad that that couldn't happen, but then I thought, wait, what if everybody could do the experiments? Not on stage, but at home. But you see, I don't want to just show you a demonstration, because that's not really what science is. I want to show you how you can create your own investigation and suggest some things that you might like to try. Science isn't about knowing facts. It isn't about memorising information and being able to repeat it. Science is about asking questions and finding a way to work out the answer to that question. So you might have made an Alka Seltzer rocket before. If you haven't, then not to worry, I'm going to do a quick recap. Here I have a film canister. The film canister itself is not all that important. It's simply a small container with a lid that can be made to pop off. Now for every experiment, it's important that you think about safety. There might not be much chance of you getting hurt in some experiments, but for this, I need to wear eye protection and I'm going to make sure I stand well back. Make sure to think carefully about safety before you carry out your investigations. If I put a small amount of water into the film canister, the exact amount isn't important, it's about 1 centimetre high, and then I get an Alka Seltzer tablet and I drop it in. Without too much dilly-dallying, I put the lid on, I turn it upside down, and I stand well back. And then I wait. Now that in itself isn't really science. You might like to consider carefully what's happening. You might like to look at the carbon dioxide bubbles being created when the Alka Seltzer reacts with the water. You might like to think about the pressure building up inside the canister and the friction that keeps the lid on until it can't contain the pressure and the canister flies up in the air. But you might be starting to wonder, what would happen if I used 2 Alka Seltzer tablets? You might be wondering what would happen if I break them into smaller pieces. You might be wondering about using more water or less, or even water that was a different temperature. Don't just do a science demonstration, because things get really interesting when you start making some changes and investigate what the effects are. I'm not going to show you, I'm not going to tell you the answer to those questions, but I would like to encourage you to find out for yourself. I use these Alka Seltzer Gold tablets because they're safer for use with children than the standard version, although you do still need to be careful not to put them in your mouth because they're essentially medicine. Taking medicine when you don't need it can be quite bad for you. You can use any effervescent tablets. Some vitamin tablets will also fizz in water. You do need to be careful not to lean over your container because otherwise it could easily hit you in the eye or in the face. If you don't have anything like a film canister at home, then speaking nicely to someone in a camera shop or somewhere like Boots where they develop camera film can be a good place to start. If you still can't find one, you can use a fruit shoot bottle with this little bit at the top closed. Failing that, I just bought my film canisters online. Because this is the Christmas lectures, I thought we could do it with 1 or we could do it with 64. So here we go. Take cover. One more. Will it go? 63. Another experiment you might like to try is this one using static electricity. You might already have some balloons inflated decorating your house, and you might already know that if you rub a balloon, then you build up a charge on the balloon. That means that when you bring it near another object, similar charges are repelled and opposite charges are attracted, meaning that you also build up a region of charge in the other object. You can investigate the effect of this on various household objects, such as an empty drinks can or a stream of water from the tap. For the clearest results, you want your stream of water to be constant, not dripping, but the slowest it can possibly be. If you live with anyone with long hair, you might like to bring your charge balloon near to them to see what the effect is on their hair. For all of these experiments, it's important not to allow the balloon to actually touch the object. If you do this, the charges are able to move from one object to another and thereby neutralising the balloon. Don't worry if it does happen, just rub the balloon to charge it again and off you go. You might like to have a go at chromatography. While it sounds like a long and complicated word, it's really just about separating a mixture into its parts. For example, here I have some felt tip pens. There's a few black ones, and you wouldn't really be able to tell much difference if I wrote you a note with each of them, but there's actually a massive difference in the inks used in each of these pens. This is just a coffee filter that I got from home, and if you cut it open along the join, then you end up with one piece rather than it being folded double. You'll need to draw a line in pencil using a ruler a couple of centimetres from the bottom. It's really important that when you put it in water, the water is below the pencil line, so don't do it too close to the edge. Don't worry, the filter paper will soak up the water really well, so it only just needs to be touching the water at the bottom. I'm then going to put a hefty dot or a small circle in pen along the pencil line. Leave a bit of space between them as they can spread out a little bit then. And when it's finished, secure it with a paper clip. I'm going to drop it into a container where it won't touch the sides. It's best to add the water using a jug so that you don't accidentally add too much. Stop when the water is below the pencil line and let the water do the work. What you'll see is that over time, the colours will spread out and you can see what each of these inks are made up of. You could have a look at home and investigate the colours that make up your felt tips. Black works particularly well, and some of them you may find are actually only made up of one colour. Permanent markers won't work because the ink doesn't dissolve in water, so it's best to use washable felt tips for the clearest results. The final experiment I want to show you is one I'm sure you will have seen before, and you might even have done yourself: Mentos and Coke. Remember though, science isn't just about knowing what's going to happen or memorising some facts, and science isn't about performing a magic trick. It's about asking questions and then trying to work out the answer to the question. So you might like to investigate: what's the best number of Mentos to add to the Coke? You might want to try some different sweets. Some might work spectacularly and some might have no effect at all. What happens if the Coke is a little bit warm or a little bit cold? And does it make the fountain higher, last longer? Does it make it more explosive? I'm going to need some cola. I hope that you'll enjoy yourselves and have some great fun doing experiments at home, at school, or with friends or family. As long as you're careful to stay safe, it's good to ask questions, design experiments to answer those questions, and find out the answers for yourselves.